The positive integers from 1 to 99 are written in order next to each other to form the integer 1, 2, 3, and so on, all the way up to 98, 99. How many digits does this integer have? So this big long integer, from 1 to 9, just those numbers, there will be 9 integers. And then from 10 to 99, each of those will have 2 integers, right? 10 has 2 integers, 99 has 2 integers. And how many are there? From 10 to 99 inclusive, there's 90. There's 90 numbers, and each of them has 2 integers, so 90 times 2, which is 180. So we have to take this 9 and add it to that 190, and when you do, you get 189 integers or digits that are a part of that big long number. Part B. The positive integers from 1 to 199 are written in order next to each other to form this big long integer. How many digits does this have? Okay, so same kind of story. From 1 to 9, there's going to be 9 integers. From 10 to 99, there's going to be 90 times 2, which is 180 digits or integers, whatever. And then from 100 to, what are we going up to, 199, that is 100 numbers, and each of them has 3 digits, right? This one has 3, this one has 3. So that's 300. So then we just have to add up these guys, and that's what, 389? No, 489. Yeah, 489. Okay. All right. Moving right along, part C. The positive integers from 1 to n are written in order next to each other, resulting, if the resulting integer has 1155 digits, determine n. Okay, so a little bit different this time, but I think we can follow pretty much the same pattern as these two. Okay, so 1 to 9, that's 9 digits. Now we have to go up to that many, so that's a lot. So let's just keep going here. From 10 to 99, that is 90 times 2 digits, which is 180. So far we have 189, but we have to get up to 1155. So I think we could probably get up there with 3-digit numbers. So from 100 to n, I'm pretty sure n will be a 3-digit number. From 100 to n, the number of numbers is going to be n minus 99. And then each of them will have 3 digits, so that's going to be 3n minus 297. And then if you add these guys up, that is what has to equal this 1155, I believe. So that means 9 plus 180 plus 3n minus 297 is equal to 1155. So let's do this math here. This is 3n, and that'll be 1263. And then solving this, we get n equal to 421. There you go. All right, final part. The positive integers from 1 to 1000 are written in order next to each other. Determine the 1358 digit of the resulting integer. Okay. So we have 1 to 1000 are written. Okay, so and then they want the 1358 integer, I believe. Yeah, 1358. Okay, let's see what we can do here. So again, 1 to 9, that's 9 integers. 10 to 99, by now you're an expert, that's 90 times 2, which is 180 digits. And then from 100 to wait, hold on here. What am I going up to here? They don't tell me that. They just say it's 1,000 numbers. Okay, I gotta figure this out then. Well, they did give me a little clue. That little clue is that they want the 1358 digit. Now, so far I have 9 plus 180, so I have 180 digits. So the 1358 minus this 189, I should say, is 1169. So this has to somehow be giving me another 1169. Yeah, I got it. That whatever this goes up to, it's going to be something times 3, right? And that's going to have to be close to 1169. Okay, well, 1169 divided by 3 is what? About 389 with a remainder of 2, I think. So I'm going to put 389 as the number of 3-digit numbers. So that's going to be 489 goes here, right? Is that right? Yeah, I think so. This is approximation. Let's see what happens here. So that means that this is going to be 390 in terms of the number of 3-digit numbers from 100 to 489. And that is 1170. So that means if I add these guys, now we have 9 plus 180 plus 1170. And that gives me 1359. So the 1359 is the total number of digits that you have if you have from 1 to 489. So 1, 2, 3, 4, dot, 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 all the way till 488, 489. So this guy is the 1359th digit. But we want the 1358. So we want this guy. So this is the 1358th digit, and it is an 8. And I believe 8 is the answer to this question. In triangle ABC, angle ABC is 60 degrees and angle ACB is 50. What is the measure of angle BAC? Okay, well, as always, the angles of a triangle add up to 180. So all of those would total 180, and therefore this would be 70 degrees. The next one, angle bisector is a line segment that divides an angle into 2 equal angles. In triangle ABC, angle ABC is 60, angle ACB is 50. If BD and CD are angle bisectors of ABC and ACB respectively, what is the measure of BDC? All right, so ABC is 60. So that means that bisector divides it into 30 and 30 for those angles. ACB is 50. So that bisector divides it into 25 and 25. And then what do they want? They want a measure of BDC. So BDC is this guy. I'll call it theta. And as always, theta plus 30 plus 25, the angles of a triangle will add up to 180. And when you solve this, you get 125. And that represents angle BDC. Next part, point S is inside triangle PQR so that QS and RS are angle bisectors of angle PQR and PRQ, respectively, with QS equal to RS. If QSR is 140, determine with justification the measure of QPR. All right. With justification. So they're getting serious here. All right. So let's see. Where do we begin here? I'll just call this theta and theta. And let's see here. QS is equal to RS, right? Oh, they even labeled it. So that means that this angle will be the same as that angle. So that means that's theta. Now, since SR, or RS, is the angle bisector of PRQ, that means this is theta. Okay, so that's pretty much basically exactly from the question. I didn't even have to do anything on my own. The question pretty much tells you those things. Okay, so now what? What do they want here? QPR. Oh, so they want this angle in here. Okay. Well, QPR, that angle, plus this whole thing, which is 2 theta, I should say. And then this whole thing, which is another 2 theta. That's going to be all 180. Correct? Yeah. Okay. So that means QPR plus 4 theta is equal to 180. QPR plus 4 theta is equal to 180. Okay. Well, that's 2 variables here. I wish I had less than that. All right, no problem. Where do I go from here? Oh, they gave me QSR. Ah, okay, I got it. I thought they didn't give me enough information. QSR is 140. Okay, well, that's easy then. Then I can just take this triangle QSR and then add up 140 plus theta is equal to 180. And there you go. Theta will therefore be 20. And then if we put this back into here, you can easily solve that. That would make angle QPR equal to 100. And finally, in triangle PQR, let's just keep it in the diagram here. QS and RS are angle bisectors of PQR and PRQ, respectively, with QS equal to RS. Explain why it is not possible for QSR to equal 80. Okay, if QSR was equal to 80, that means that this guy, QSR, if that was 180, or sorry, 80, not 180, then that plus the other two angles would equal 180, right? And if it's 80, let's see what we get. We would have 2 theta plus 80 is 180, so that means theta would be 50. Okay, so if theta is 50, then we look at the full triangle. And in the full triangle, it would be that 4 theta plus angle QPR is equal to 180. So since theta is 50, there would be 4 times 50, which is 200, plus angle QPR is equal to 180. And therefore, angle QPR is equal to minus 20. And since angles cannot be negative, this will not work. So you can just explain that in a sentence format that since QPR ends up being negative 20 degrees, we cannot start with QSR being 80 degrees. Triangle ABC begins with vertices A, B, and C. As shown, 2 players play a game using triangle ABC. On each turn, a player can move a vertex A 1 unit either to the left or down. The XY coordinates of A cannot be made negative. The person who makes the area of triangle ABC equal to 25 wins the game. What is the area of ABC before the first move is made? All right. Well, let's just join these first. A to B, like that. And then this will be my altitude. The area is 1/2 base times height. The base looks like from B to C is 10. And the height, well, that's the altitude. So that's going to be the y coordinate of A, which is 9. And that is 45. Part B. Dexter and Ella play the game. After several moves have been made, vertex A is at 2,7. It is now Dexter's turn to move. Explain how Ella can always win the game from this point. All right. Well, this is sort of that diagram wherever we are. And they're saying that A is now at 2,7. So A is now 2,7. So this altitude is 7. And I believe C is the same, right? And C was at 10. So right now we have, in terms of the area of that triangle, 1/2 base times height. So let's see here, 1/2 base times height, which is 7. So that's going to be 35. Now we want an area of 25. So in order to get an area of 25, 1/2 base, the base is always going to be 10, and the height, which is basically this guy, the y coordinate of A, so I'll just call it y. So we have 25 is equal to 5y. So the y coordinate y has to be 5. Okay, so that helps. All right, so let's see what we get here. Let's make a little table. We have Dexter, and we have Ella. And let's see what we get. All right. So we have, well, Dexter can, it's now Dexter's turn to move. So he has a choice. He can either go left or down, right? Those are the two choices? Yeah, left or down. Okay, so if he goes left, let's start off with him going left. if he goes left, then he started here. That means he would therefore be at 1, 7. Now, Ella, essentially her goal is to have a y coordinate of 5. So what she can do is she can go left again. And if she goes left again, then this will go to 0, 7, correct? And then Dexter has he can't go left because remember, you can't have negatives. It says that in the question that A cannot be made, the x and y coordinates cannot be made negative. So therefore, he has no choice but to go down. So if he goes down, this goes down to 0, 6. And then she just goes one spot down as well, and that goes down to 0, 5. And then once the y coordinate is 5, then the area will be 25. So that's her strategy. But what about if Dexter started by going down, right? Well, then that 2, 7 would go down to 2, 6, I believe. And then at that point, Ella can also do the same move, go down, and that would make this 2, 5. And there you go. She's got 5 as her y coordinate, and she will win the game. So that's the strategy there. Next part here. Faisal and Jeff played the game with Faisal always going first. There is a winning strategy for one of these players. That is, by following the rules in a certain way, he can win the game every time, no matter how the other player plays. Okay, which one has a winning strategy? All right, which one has a winning strategy? Okay, so I guess we'll explain it all, sort of 1, 2, 3, points 1, 2, 3 here. And the first question, we are starting at 6, 9, that's the beginning. And the first player is going to be this guy, Faisal. And obviously the second player is Jeff. And he says, which one of the players can have a winning strategy? It's going to be the second player. Yeah, the second player. And the part B of this question actually kind of showed you that the second player can always figure out how to win. So in terms of which one of these two players, it's Jeff. Now, you say, well, why? Okay. Well, again, part B of this question kind of showed you how. And the key there is that in order for Jeff to guarantee a win, he has to basically perform the exact same moves as Faisal. Same moves as Faisal. And if he does, he will win. And of course, the goal eventually being that we want the y coordinate to be equal to 5. So Jeff wants his y coordinate. All right, so now I have to justify it, right? I have to show how this works. Okay, so I will. So here we go. Let's show how this works. So we have Faisal, Jeff, and then Faisal and Jeff and like that, right? And then we'll do the moves and we'll figure out the coordinate for A. We're starting at 6, 9, right? Okay, so Faisal goes first, and let's say he goes down. Then Jeff has to go down as well. Remember, that's the strategy, that he's got to perform the same moves as Faisal. So it started at 6, 9. It's going to be 6, 8. And then it's going to be 6, 6, like that. Correct? So when he goes down, this goes down to 6, 8. And then this goes down to 6, 7. And then he goes... wait, hold on. I think I wrote that wrong. Yeah, I should write it here. 6, 8, and then Jeff goes down, and it becomes 6, 7. Okay, got it. And then at this point, let's say phasal goes down again to 6, 6. And then Jeff just uses this strategy and goes down once more. And then once you're at 6, 5, he won because his y-coordinate is 5. That's just one scenario. Okay? Now, you say, well, there's other scenarios, right? Well, of course, there's many, many other scenarios. But you can always sort of see that Jeff can just use the simple rule of performing the same moves as phasal to eventually win. Let's try another scenario. Again, phasal, Jeff, and so on. And let's say instead of him going down, he's going left this time. All right, so the move and then the coordinate, right? So he goes left, and that means this goes down to 5, goes back to 5, 9. Left again, 4, 9. And then left again, 3, 9. And then left again, 2, 9, and so on, right? And then eventually, if you keep going left, this will be 1, 9. And then if you keep going left, this will be 0, 9. Right? But at 0, 9, phasal or Jeff or anybody can't go left again because you can't have negative numbers. That's one of the rules. I think that's in the somewhere in here. Oh yeah, right here. The coordinates cannot be negative. So we at this point have no choice but to go down. So if you go down, this will be 0, 8 for phasal. And then you get the idea. 0, 7. Phasal, Jeff 0, 6. And then finally Jeff 0, 5. And then once you get down to 5, then since the y-coordinate is 5, the area will be 25 and Jeff wins. Now, any other combination will be a combination of these guys, and you will always be able to end up with 5. Well, Jeff will always be able to end up at 5. So you can explain that in sentence format, that as long as this basic rule is followed, Jeff will always be able to win. The set A, 1, 2 has exactly 4 subsets. The empty set, 1, 2, and 1, 2. The 4 subsets of A are 0, 1, 2, and 3, respectively. The subset sums. The sum of the subset sums of A is 0 plus 1 plus 2 plus 3, which is 6. Note that the empty set is the empty set, and that 1, 2 is the same as 2, 1. The set 1, 2, 3 has exactly 8 subsets, and therefore has 8 subset sums. List all 8 subset sums of 1, 2, 3. Okay? So we have the empty set. Then we have the set 1. I'll just use those types of brackets, easier for me. The set 2, the set with 3, the set with 1, 2, the set with 1, 3, the set with 2, 3, and the set with all of them. So these are the subsets, right? And there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, just like how they sit. Now we want the sums. Well, this is 0 because there's nothing inside. Sum here is 1, 2, 3, 3, 4, 5, and 6. And then the total sum, actually they don't ask for that, right? They just want the sums. But I'll just put the total sum. Just doesn't matter. I guess we're just adding up all these guys. And when you do, I believe you get 24. Yeah. 10, 13, hold on. Yeah, 24. Okay. Let's keep moving on. This question. Determine with justification the sum of all the subsets of 1, 2, 3, 4, 5. Oh, okay, so there's a lot more work involved in this one here. Okay, so let's see if there's instead of listing them out, which would take forever, let's see. The number of elements in the set. Let's break it up by that. And this is, so we got 1, 2, 3, 4, 5. Okay. If the number of elements is 0, 1, 2, 3, 4, and 5. If it's 0, that means it's just the empty set. correct? And therefore, the sum will be 0. Okay, that's pretty straightforward. If the subset has only 1, that means you have either a 1, a 2, a 3, a 4, or a 5, those kinds of guys. And the sum there is 15, the sum of all these guys, the sum of the subsets. Okay, now we're going to have a lot to list. So I'm going to try to figure out a way of oh boy. Yeah, there's a lot. Actually, there's not that many, but let me just see. 1, 2, 1, 3. I just didn't want to list them all. 1, 4, 1, 5. And then you'll have the 2, the 2, 3, the 2, 4, the 2, 5. And then you'll have the 3, 4, the 3, 5. And then finally you'll have the 4, 5. Okay, so that's actually not so bad. So there was, a number of subsets. Let me put that in there. So this was 1, just this guy. Here we had 5, 1, 2, 3, 4, 5. And here it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. And then we have to add up these. So you can do that. This 1, 2 is 3, 1, 3 is 4, and add up all those guys. You can do that. And when you do, you get a sum for these guys of 60, I believe. Okay, so as you can see, a little time consuming here. And let me just give myself a little bit more space here. So 3, 4, and then 5. Now, the next one, I'm not going to list them. I'm going to figure out a way of figuring out how many there are with sort of like probability, combinatorics, that kind of thing. So, for example, if you have 3, then for the first one, we have 5 choices, right, from these guys. The next one, we have 4 choices. And then for the last one, you have 3 choices. So then you multiply them. That's how many different choices. But there's a lot of doubles in here, because each one of these has 6 different combinations, right? Because, for example, if you have 1, 3, and 5, that is the same as 3, 1, 5. And that's also the same as 3, 5, 1, and so on. There's 6 different possible ways of making this guy. So we have to divide by that. So really what we're dividing by is 3 factorial. I hope that makes sense. Let me just list them. 1, 5, 3, and then 5, 3, 1, and then 5, 1, 3. So you notice how one of these guys has 6 possible ways of writing, and all 6 are considered the same. So since there's so many doubles, you have to divide by that. So and then when you do this, you get, I believe, 10. So that means that there's 10 of them. And now we have to come up with the sum. How do we come up with the sum? Oh, since there's only 10, I got to list them all. Oh boy. All right, I'll list them. 1, 2, 3. I wish there was a faster way. 1, 2, 4. 1, 2, 5. And then 1, 3, 4. 1, 3, 5. 1, 4, 5. 2, 3, 4. 2, 3, 5. 2, 4, 5, and finally 3, 4, 5. Okay, that's not so bad. And then each of these has a sum, and then when you add up all the sums, you get 90. Yeah. So I hope you're getting the idea here. Okay, so now we can go up to the ones with 4. So the same kind of thing. 1, 2, 3, 4. So you have 5 possible choices for that guy, 4 for that, 3 for that, and then 2 for that. And then you have to multiply them, but then there's going to be a bunch of doubles. So you have to divide by the 4 factorial this time. And when you do, this gives you 5. So there's only 5 here. And you can easily list those. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 4, 5. 1, 3, 4, 5. 2, 3, 4, 5. Yeah, just these guys. And then the sum is 60. And then finally 5. Well, 5 is just all 5 of them. You just list them. That's the only set that has all 5, and the sum here is 15. So there's only one of those guys. Okay, so now we want the totals. Okay, well, we have to add this guy, this, and that. So that is going to be 150, 210 plus 30 is 240. So the grand total is 240. And I believe that is what they're looking for. And the final part, 4C. Determine with justification the sum of all subsets, sums of 1, 3, 4, 5, 7, 8, 12, 16 that are divisible by 4. All right, so how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8 numbers in that set. Okay. Now, before I tackle this, I want to go back and look at 4B again, just to kind of give you an idea of how we can make our life a little bit easier. In 4B, if you remember, there was one subset. If you look at the number of subsets, the number of elements, and the sum of those subsets, right? This whole thing, this what we did. If I made a little table here really quickly, it was, let's see here, if I remember. So this was 0, 1, 2, 3, 4, and 5, and the number of elements. Sorry, this is what I meant was 0, 1, 2, 3, 4, 5. Should be there, and the number of subsets I believe were 1. What was it? Oh, here it is. 1, 5. 10, 10, 5. Okay. So it was 1, 5, 10, 10, 5. So 1, 5, 10, 10, 5, and then 1. Right. There was a 1 in there somewhere. Oh, I think I might have erased it, but whatever. And then the sums here was 0, because that was just the empty set, but then the sum here was 15, 60, 90, 60, and 15, and the totals, this was 240. Yeah. Okay, so what I did was I said, well, is there any way that we could estimate this? And this is a little bit of a leap of faith, but this 240 is really 16 times 15, right? Because I noticed that this 15 and multiples of 15 keep coming up. So I thought, well, how many multiples of 15? 16 multiples of 15. Now 16 is 2 to the power of 4. And this 15 is really 1 plus 2 plus 3 plus 4 plus 5. Okay. Then I went back and said, well, my original set that they were looking at was this guy right here, right? And that, 1, 2, 3, 4, 5, that was the original set, right? 1, 2, 3, 4, and 5. Well, that looks a lot like that guy. And then this, 2 to the power of 4, immediately doesn't give me anything, but perhaps that 4 is referring to the number of elements in the set, or 1 less than the number of elements. You see, I mean, like, really kind of fiddling around to see if there's anything we can do, because there's a lot of elements here, and it would take absolutely forever. So you take a leap of faith and you say, okay, well, this is what I think. Based on what I've done over here, this guy, I think with that set, it's going to be 2 to the power of 7 this time, because there's 8 elements, and I believe that this number refers to 1 less than the number of elements, which was 5. And then I multiply by the sum of the elements. So 1 plus 3 plus 4 plus 5 plus 7 plus 8 plus 12 plus 16. And that will be my sum of the subsets. And this turns out to be 2 to the power of 7 times 56, which is 128 times 56, which is 7168. Now, I know that's very difficult to come up with on your own, but that's why it's the last question of the contest. Okay, but we're not done yet. We think, well, okay, great, I'm done, right? But no, because they want only the sum of all subset sums that are divisible by 4. So we only want sums divisible by 4. We only want sums divisible by 4. All right. Okay, so that means only multiples of 4 are really going to be kind of in play here. So this is what we do. We kind of have to take this one step at a time. All right, so let's go through this. The first is, let me just write down what we're dealing with here. We're dealing with the set 1, 3, 4, 5, 7, 8, 12, and 16, right? Yeah. Okay. So the first is if we can have only multiples of 4. Like we make subsets out of numbers that are multiples of 4 already. And that way, guaranteed, everything will be a multiple of 4. So just take numbers from this original set that are multiples of 4. And we do the same thing. So we use our handy-dandy formula, right, this guy. And we see that it would be 2 to the power, well, there's 4 elements, so we'll put a 3 there. And then we add up these guys. So 4 plus 8 plus 12 plus 16. And that is 320. So you see how quickly I did that without having to list all of them and counting all of them. So that's sort of our strategy. Now this one is guaranteed that this scenario is that every subset will be a multiple of 4. But there's going to be other subsets, right, that we can create from using numbers from that original group of 8 numbers. But all the other ones, we have to use these guys because that's sort of the foundation. So that means that all of the above subsets from this guy, we have to then add either, well, some of these other numbers. So either 1 and 3, right, because 1 plus 3 is 4, or 1 and 7, because 1 plus 7 is 8, 3 and 5, because 3 plus 5 is 8, 5 and 7, because 5 plus 7 is 12, or there's one more, I think, 1, 3, 5, and 7, that one, because that would be 4 plus 12, which is 16. Yeah. That would do it. Okay, so let's take this one step at a time. We're going to have to do 1, 2, 3, 4, 5 more scenarios plus this base value of 320. Okay, so we're going to have to do 1, 3 plus the 320, 1, 7 plus the 320, 3, 5 plus the 320, 5, 7 plus the 320, and then 1, 3, 5, 7 plus the 320. All right. Okay, so let's see what we get, and then we'll add them all up. Well, 1 and 3, that is has a sum of 4, And we have to add that to all the subsets. Now, how many subsets were there? I think that's probably something that is important back in here. Well, if the element had only one number, then there would be 4 subsets, right? 4, 8, 12, and 16. If the subset had 2 elements, there would be 6, and you can list them: 4, 8, 4, 12, 4, 16, 8, 12, 8, 16, and 12, 16. If the element had 3, if the subset had 3 elements, then there's going to be 4, and you can list them all. And then if the subset had 4 elements, there's just 1. It's just 4, 8, 12, and 16. So this total is what? Oh, there's another one. If there's 0, if there's an empty set, it's 1. So I guess we have to add that one. So that's going to be 10 plus 6, so 16. So 16 total. So for each of those subsets, you're going to add this 4. And therefore, you're going to have 16. So that's going to be 16 times 4 plus the base of 320. And that gives me 384. All right. So that's pretty much the pattern here. Next one, same thing. This time we have an addition of 8, because 1 plus 7 is 8. And then again, you're going to have 16 subsets from up here, this guy. And each of them will have an additional 8. So 16 times 8 plus the 320. And that gives me 448. Moving right along, this one again is 8. So it's the same thing. 16 times 8 plus 320. That's 448. And then this one is 12. So 16 times 12 plus 320. And that is 512. And then we have this one. Oh, this one's a little bit different then. This is now, what's the total here? 16 this time. So it's 16 times 16 plus 320. And that is 576. So now we have to add all these guys. This 320 plus 576 plus 512 plus 448 plus 448 plus 384. And when you add up all those guys, you get 2688. And that is the answer, final answer to this question.